We will understand the concept of elasticity in this module. We will begin with understanding what is a market. A market is a place where both consumers and producers meet together to buy and sell commodities to each other in exchange of money. There are different market structures that we will be doing them later in the later modules in detail, which has different characteristics of the quantity of buyers and sellers along with some other characteristics like the type of product, the price and the quantity of the product, different cost of production, entry and exit barriers, etc. We will start with the market with many buyers and sellers. Here, buyers are also known as demanders and sellers are also known as firms or producers, where each firm produces a good or a product or a commodity using the factors of production, and then we'll discuss the concept of elasticity in detail.
After studying this module, you shall be able to know the meaning of elasticity and its different types, learn how to calculate price elasticity, income elasticity, cross elasticity, and supply elasticity. Identify the determinants of elasticity of demand. Identify the determinants of elasticity of supply. The main motive of all individuals is to spend their income for purchasing the products in order to maximize their utility or satisfaction. Though utility is hard to measure, but a person can maximize his utility given the availability of the resources. The amount of a product that consumers wish to purchase is known as quantity demanded. Here, quantity demanded is a flow variable and it is a desired quantity which consumers wish to purchase in a market from the sellers. There are five main factors which affect the quantity demanded of a product by each individual consumer, namely price of the product, prices of the other or related products, income and wealth of the consumers, taste and preferences of the consumers, various individual specific or environmental factors. The above factors are also known as the determinants of demand. The factors determining demand can be shown in a functional form as follows. D is equals to F Px, PR, Y, T, S. Here D stands for the demand of the good X, F represents the function, Px stands for the price of the good X, PR is the price of the other related good, Y stands for the income and wealth of the consumers, T represents different taste and preferences of the consumers, S indicates all the other environmental and consumer specific factors. The demand function states that the quantity demanded of a product by a consumer depends on the price of the product, price of its related product, income of the consumers, and all the other specific and environmental factors. The form of the function determines the nature of that dependence. The supply of the goods and services is done by the firms, therefore the firms are known as the suppliers. The main motive of the firm as a supplier is to make profit by selling its goods and services to its ultimate consumers. For this, they hire several factors of production to which they pay their payment. After that, the firms decide about the prices at which they will sell their product in the market, keeping in view the maximization of their profit. The amount of a product that the firms are able to and willing to sell in the market to its consumers is known as quantity supplied. Supply is a flow variable which is affected by the following factors: the price of the product, the price of the inputs or factors of production, the state of technology, The above factors are also known as the determinants of the supply. The factors affecting supply can be shown as a relationship S is equals to F Px, F1, Fm, T, where S is equals to quantity supplied, Px is equals to price of the good X, F1 till Fm is equals to prices of all the inputs of production, T is level of technology. Price elasticity of demand is defined as the percentage change in the quantity demanded divided by the percentage change in the price of the commodity. Algebraically, ED is equals to percentage change in quantity demanded divided by percentage change in price. Price elasticity also shows the degree of responsiveness of the change in the quantity demanded of a product due to the change in its price. The above equation can be written as ED is equals to change in Q by Q into 100 divided by change in P by P into 100 is equals to change in Q by Q divided by change in P by P. Thus, ED is equals to change in Q by change in P into P by Q. Now, since there exists inverse relation between the price and the quantity of a product, therefore, as the price increases, the quantity demanded falls. Therefore, the value of price elasticity will always be negative. In order to overcome this, we add minus sign in the above equation itself so as to get the positive elasticity, because it is easier to apply further applications on positive numbers. Hence, the new and final elasticity formula becomes ED is equals to minus change in Q by change in P into P by Q. Now, we will understand the meaning of demand elasticity. According to Lipsey and Crystal, demand elasticity is measured by a ratio, the percentage change in the quantity demanded divided by the percentage change in the price that brought it about. For normal, negatively sloped demand curves, elasticity is negative, but the relative size of the two elasticities is usually assessed by comparing their absolute values. The larger value of elasticity indicates that the quantity demanded is highly responsive to a little change in the price. That is, quantity demanded changes more than as compared to the change in the price. On the other hand, the smaller elasticity indicates that the quantity demanded is relatively unresponsive to a change in the price. That is, the quantity demanded have a little change as compared to a change in the price. The value of price elasticity of demand varies from 0 to infinity. According to Lipsey and Crystal, elasticity depends on the slope of the demand curve and the point at which the measurement is made. Starting at point A and moving to point B, the ratio change in P by change in Q is the slope of the line, while its reciprocal change in Q by change in P is the first term in the percentage definition of the elasticity. The second term is P by Q, which is the ratio of the coordinate of point A. Since the slope change in P by change in Q is constant, it is clear that the elasticity along the demand curve varies with the ratio P by Q, which is 0 where the curve intersects the quantity axis and infinity where it intersects the price axis. Moving on to the different demand curves. First, zero elasticity implies that the quantity demanded does not change with a change in the price. That is, quantity demanded is completely unresponsive to a change in the price of the commodity. In such case, the demand curve is said to be perfectly inelastic. Infinite elasticity implies that the quantity demanded is highly responsive to a change in the price. That is, even with a very little price change, the change in quantity demanded is huge. In such case, the demand curve is said to be perfectly elastic. If the value of elasticity is 1, then it represents that the quantity demanded is equally responsive to a change in its price. That is, quantity demanded changes in the same proportion in which price changes. In such case, the demand curve is said to be unit elastic. However, if the value of elasticity is greater than 1, then it is known as more than unit elastic and represents that the change in the quantity demanded is greater relative to a change in the price. In such a case, the demand curve will be downward sloping but flatter in shape. On the other hand, if elasticity is less than 1, then this is known as less than unit elastic, and in such a case, the demand curve would be steeper and downward sloping as it represents a lesser change in the quantity demanded relative to a change in the price. When the price elasticity is measured between any 2 points, then it is known as arc elasticity. The arc elasticity is measured by the following formula. ED is equals to change in Q by change in P into P naught plus P1 divided by Q naught plus Q1. When the elasticity is measured for a point on demand curve, then it is known as point elasticity. The point elasticity is measured by the following formula. ED is equals to change in Q by change in P into P by Q, or ED is equals to lower segment divided by upper segment. For instance, the point elasticity at point P could be calculated as follows. ED is equals to lower segment divided by upper segment. Thus, ED is equals to Pn divided by Pm. Now, we will understand the relationship between elasticity and total spending. The total spending of the product's buyer is always equal to the money received by the product seller plus the taxes levied by the government. For simplicity, let's ignore the taxes and just take total spendings of buyers to be equal to the money which sellers receive. Moving on, we know that a change in the total spending brought by a change in the price of the product is directly related to its elasticity of demand. If the elasticity is less than unit elastic, then the percentage change in the price will exceed the percentage change in the quantity, and this price change is so influential that this will lead to change the total spending of the buyers in the same direction as the price changes. However, if the elasticity would be more than unit elastic, then the percentage change in quantity will exceed the percentage change in the price, and this change in quantity will be so influential so as to change the total spending in the same direction as it changes, opposite direction to the change in price. Hence, based on this thing, we can draw the following outcomes. When elasticity of demand is less than unit elastic, a fall in price reduces the total spending on the product and a rise in price increases it. When the elasticity of demand is more than unit elastic, a fall in the price will increase the total spending on the product and vice versa. When elasticity of demand is unity, then a rise or fall in prices leaves the total spending on the product unaffected. That is, total spending do not change. The next topic we need to understand is the income elasticity of demand. Income elasticity of demand is defined as the percentage change in the quantity demanded divided by the percentage change in the income of the consumer. Algebraically, EM is equals to percentage change in quantity demanded divided by percentage change in the money income. Income elasticity also shows the responsiveness of the change in the quantity demanded of a product due to the change in the income of the consumer, represented as M. The above equation can be written as EM is equals to change in Q by Q into 100 divided by change in M by M into 100 is equals to change in Q by Q divided by change in M by M. Thus, EM is equals to change in Q by change in M into M by Q. Now, since there exists a direct relation between the income and quantity of a normal good, therefore, as the income of the consumer increases, the quantity demanded also increases. Therefore, the value of income elasticity will always be positive for a normal good. However, since there exists an inverse relationship between the income of the consumer and the demand of the inferior good, therefore, as the income of the consumer increases, his demand for inferior good reduces, and hence the income elasticity will be negative for inferior goods. Next, we have cross elasticity of demand. Cross elasticity of demand is defined as the percentage change in the quantity demanded of one commodity divided by the percentage change in the price of the other commodity. Algebraically, EC is equals to percentage change in quantity demanded of X divided by percentage change in the price of commodity Y. Cross elasticity also shows the responsiveness of the change in the quantity demanded of a product due to the change in the price of the other product. The above equation can be written as EC is equals to change in QX by QX into 100 divided by change in PY by PY into 100 is equals to change in Qx by Qx divided by change in Py by Py is equals to change in Qx by change in Py into Py by Qx. Since there are different goods available in the market, therefore the cross elasticity would depend on the nature of the goods. In case of the substitute goods, if the price of one good increases, people shift their demand from that commodity to its substitute commodity, and thus the demand for the other commodity increases due to an increase in the price of the first commodity. Hence, cross elasticity in case of substitute goods would be positive. In case of complementary goods, when the price of one good increases, the demand for its complement reduces because they can be used in fixed proportions. Hence, in case of complementary goods, the cross elasticity of demand will be negative. In case of unrelated goods, even if the price of one good increases or decreases, it leads to no effect on the demand for the other good. Hence, in such a case, the cross elasticity of demand for unrelated goods would be zero. The factors that affect the price elasticity of demand are: first, availability of substitutes; second, nature of the commodity; third, proportion of income spent; fourth, time factor; fifth, alternative uses of the commodities. Availability of substitutes. The closer the substitute, the higher is the price elasticity of demand. This is so because if there will be availability of close substitutes, then if the price of the commodity changes by a minimal amount, then people will start substituting it with its substitutes, and thus there is going to be a great change in the demand of the commodity. Nature of the commodity. If the commodity is a luxury good, then the price elasticity would be higher. That is, the demand is more elastic for the luxury goods because the consumption of luxury goods could be postponed if the price of them increases. However, the demand of necessary good is inelastic in nature because even their prices change their consumption is almost necessary for the consumer and he cannot postpone his demand for necessary good when its prices increases. On the other hand, the demand for the comforts is more elastic than that of necessities and less elastic than the demand for luxuries. Next, proportion of income spent. If the proportion of income spent on the purchase of a good is too small, then its demand is inelastic and vice versa. This is so because even if the price of these goods increases, then it leads to almost no change in their consumption. For example, salt, matchbox, etc. Moving on to time factor. If the purchase of a good could be postponed, then it has lesser elasticity, and if it cannot be, then it has a higher elasticity. In short, the shorter the time taken, the greater the elasticity. For instance, if the price of TV reduces, then people who have a better purchasing power will buy it, and hence its demand because of short time taken for purchasing it. However, if people could postpone its purchase, then even if its prices has decreased, demand will not increase. Alternative uses of the commodities. The wider the range of alternative uses of a product, the higher the elasticity of its demand for decrease in price and the lower elasticity for rise in price. For instance, milk, water, electricity, etc. Let us now understand how can we measure price elasticity through a linear demand function. Suppose a linear demand function is given as Q is equals to A minus B into P. Given the demand function, the formula for measuring the price elasticity of demand, that is EP, through a demand function can be expressed as follows. EP is equals to minus B into P by Q, where B is equals to change in Q by change in P. The derivation of this is as follows. Given the demand function, the total demand at a given price, say P1, can be estimated as Q1 is equals to A minus B into P1. When price changes from P1 to P2, the total demand can be worked out as Q2 is equals to A minus B into P2. Given the formula for measuring the price elasticity, we need two ratios, minus change in P by change in Q and P by Q. Given the demand at two different prices, P1 and P2, the ratio change in P by change in Q can be obtained as follows. Change in Q by change in P is equals to Q2 minus Q1 divided by P2 minus P1 is equals to A minus B into P2 minus A minus B into P1 divided by P2 minus P1 is equals to minus B. By substituting minus B for change in Q by change in P in the elasticity formula, we get EP is equals to minus B into P by Q. Alternatively, change in Q by change in P can be obtained, especially in the case of point elasticity, by differentiating the demand functions Q is equals to A minus BP. Change in Q by change in P is equals to change in A minus B into P divided by change in P is equals to minus B. Here, minus B denotes the decrease in quantity demanded when price increases by rupees 1. Given a demand function, price elasticity can be expressed as EP is equals to minus B into P by Q. Given this formula, the price elasticity can be measured by substituting the numerical values for A, B, P, and Q from an estimated demand function. Suppose a nonlinear demand function of multiplicative form is given as Q is equals to A into P to the power minus b. By differentiating demand function, we get delta Q by delta P is equals to minus B into A into P to the power minus B minus 1. By substitution, price elasticity formula given in can be written as EP is equals to minus B into A into P to the power minus B minus 1 into P by Q is equals to minus B into A into P to the power minus B minus 1 into P divided by Q is equals to minus B into A into P to the power minus B divided by Q. Since Q is equals to A into P to the power minus B, by substitution can be written as EP is equals to minus B into A into P to the power minus B divided by A into P to the power minus B, which is equals to minus B. This shows that price elasticity coefficient in case of a power demand function equals the power of price P and remains constant. It does not change with the change in price. Price elasticity of supply is defined as the percentage change in the quantity supplied divided by the percentage change in the price of the commodity. Algebraically, ES is equals to percentage change in quantity supplied divided by percentage change in price. Price elasticity of supply also shows the responsiveness of the change in the quantity supplied QS of a product due to the change in its price. The above equation can be written as ES is equals to change in QS by QS into 100 divided by change in P by P into 100 is equals to change in QS by QS divided by change in P by P. Thus, ES is equals to change in QS by change in P into P by QS. Now, since there exists a direct relation between the price and quantity supplied of a product, therefore, as the price increases, the quantity supplied also increases. Therefore, the value of price elasticity of supply will always be positive. The factors that determine the price elasticity of supply are 1. Time factor, 2. Law of diminishing returns. In a short period, the supply of a good is fixed and inelastic. However, in the long run, it tends to be elastic because long run provides opportunities to the suppliers to increase their production, investment, technology, and all. Moving on to law of diminishing returns. If the law of diminishing returns comes at an early level of production, then the cost of production will increase rapidly. As a result, supply of the good will tend to become less and less elastic.
Let us now summarize what we have learnt in this module. In this module, we have thoroughly explained the meaning of demand and supply and then explain their respective elasticities through various ways. We have also explained the determinants of elasticities which affect the elasticity of different products in different ways.